Hey everybody, this is Mr. Munson, and we're in Unit 1, Geometry Basics. And so in this video, you're going to be experiencing the information that you'll need in order to accomplish 1.5, classifying angles, and 1.6, which comes on later on. And that's just adding angles and being able to write equations. Let's go ahead and get started. Now, if you look at your student learning map, which you would have gotten in a recent class, the student learning map tells you exactly where we're going in this unit. It has a series of I can statements embedded in each little unit. Like if you look at the 1.5 or concept 5 section, you'll see that you'll have to be able to classify angles and things like that. That's what the name of this particular concept is called. In there, you'll see on that student learning map an I can statement. It says I can measure an angle using a protractor. So here's the thing. That's an expected outcome for this unit. So if you want to test well, you're going to want to know what these I can statements say and that you can do them. If you're going to go to a quiz or a test, I would look at the student learning map, look at the I can statements, and just expect to be tested on those things. If you don't know how to do those things, or you think you do but you really don't, you certainly won't be able to test on them. Okay? So let's take a look at, first of all, using a protractor. On this particular protractor, and you should have purchased one by now, there's a 0 on that side on the inside. And over on the left-hand side, there's another 0, but it's on the outside. You use the inside numbers on this particular protractor starting on the right and going over to the left to measure the angle. Okay? And then the opposite is true with the outside numbers. So this might become, a bit tedious for you. You might have done this before in previous classes, hopefully. Otherwise, this is a great review. Let's do a couple of measuring angles with a protractor and then move on. Let's make sure that we understand how to identify angles. That looks a little bit better. How to identify angles, how to label angles, and things like that. Okay. So I'm looking at this angle, and basically what we're looking at is the angle that starts at this horizontal line, and another ray that has been pulled up, creating this inside angle. When we look at this angle, all this material or all this area that's on the inside is all called the interior part of the angle. Okay, that's the interior part of the angle. And of course, that leads us to all the stuff on the outside is called the exterior part of the angle, okay? Now, this point right here where the B's at, that's called the vertex. The vertex is where the two rays that make up the angle start from. That's vertex B. Whenever we were to name this angle up here, we would draw like an angle mark. I always put a little strike in it like that and call it A, B, C. This letter right here, the middle letter, is always the vertex. And then let's label this outside called the exterior for your notes. All right, I think we're actually ready to do the protractor stuff. All right, here we go. Let's take a look at this example. Now we're looking for the measure of angle KJM. That's how we'll write it, equals. So let's bring in our protractor, make sure we know how to set it up. We always put the vertex, in this case it's J, in the center of our protractor. We make sure we line up our protractor so that it goes straight across. The bottom ray goes through, or whichever ray we want to line it up with, goes through the 0 in the direction it's going in. Then we just simply read it. Now, I know in the video it might be difficult for you to see this, but essentially it measures up someplace between 30 and 40, and with the line I can see it, it comes out to be about 36 degrees, and that's how we write it, a little degree marker at the top. Now let me give you an angle. You're just going to simply try to mimic this on your paper, and then you're going to, using a straight edge to draw your rays, and then you're going to simply use a protractor and measure it. Your measurement is going to be slightly different from mine, but what I want you to do is become confident with the ability to use your protractor. So I'm going to draw my angle, you mimic. All right, there's the angle that I would like you to try to draw on your paper. Notice that it's slightly more than 180 degrees. Okay, draw that on your paper the best you can. everything, arrows, all the letters, the measure of angle DEF, and then use your protractor, measure it, and again, your answer is going to be slightly different than mine because you're not able to draw exactly mine. Go ahead and do that. Put me on pause. Come back and check your work. All right, here we go. I'm going to bring down my protractor, put the vertex on that center. Now I need to rotate my protractor around so it lines up with that 0. So now I'm at 0. I'm not using the numbers on the outside. I'm measuring from angle 0 all the way over, and as you can see on mine, it's right around 125 degrees. Now, we're going to be talking about the language and the vocabulary of this. Hopefully you know that that's not a right angle. It's not an acute angle, which is less than a right angle. It's an obtuse angle. It's greater than that. Okay, let's move on. All right, so let's go ahead and have you mimic drawing something like this on your paper. And now I'm going to have you identify some things about it, okay? All right, let's look at another try-it problem on your half. See, make sure you know how to do it. Hey, listen, I'm going to show you some things, some obstacles you might as you're working through. One of the things is, first of all, now the angle is over on the, pointing over the left-hand side, so you're looking at using your protractor in a different way, okay? So I would still line it up, center on the vertex, but I'm now looking at the 0 on the outside, and I'm measuring from there up to where it crosses the line on here. Now here's the problem that I'm showing you. If you look at that second ray right there, you'll see that it doesn't quite extend out over the numbers, and you want to extend that so you can get an accurate reading. Don't just sit there and say, it's somewhere around there. Just take a few seconds and extend it. All right, so I just took a straight edge and added that. I'll put this back on the vertex, and lo and behold, I can see that the measure of angle MLK is equal to somewhere around 32 degrees. Okay? Now, occasionally I'll have students use those inside numbers on a problem where they should be using the outside. Have an idea. Does that really look like 150 some odd degree or 140 some odd degree angle? I don't think so. 140 some odd degree angle is way over here someplace, right? That's a really big angle. So I want you to see that sometimes you're going to have to extend your lines. All right, next up is classifying angles, okay? So remember, you're setting up your notes. You have this line here in case you have questions. You have this question mark to help you with that. I'm putting these titles in. The student learning map has these I can statements. I'm putting it here so that you can easily have it as reference. Basically, you should be able to classify an angle by its measurement. Okay, let's take a real quick approach to these 4 angles. One is called an acute angle. One's called a right angle and a straight angle. And you've had these in a previous class, I'm sure. Acute angle is smaller than 90 degrees, and that's what that inequality down below the angle says, okay? That the x value of that angle is less than 90. Then comes the right angle, and the right angle is that it's equal to 90 degrees. The next larger angle, when you rotate this thing, this ray, as it rotates around this direction, it goes bigger than 90, then it's a obtuse angle, and of course, once it rotates all the way around, then it's equal to 180, which is called straight angle. If you need more information on that, you feel free to Google those. Yeah, just Google those and have fun with them. All right, I'm going to shrink that down, put it in my notes, and let's continue. All right, so here's an example of a problem that you might encounter. I give you an angle like this, and I say, hey, classify that angle. Now, some of you would make a guess, and maybe even guess that's a 90-degree angle. Okay, here we go. We're going to take a look at this and see if we can figure this out. So I'm going to put my protractor on the vertex, and so now I'm going to have to actually do a little bit of changing of my protractor to get it to line up. So I'm just going to get it to line up with the 0 over there. I'm lucky enough that I have a protractor that can expand, so I'm just going to make sure I can see the numbers there. Let's rotate it, get it lined up. Here we go. And so then I'm going to measure that, and I can see that where it comes across over here, it's somewhere around, let's see, at 70, 80, 90, 100. And All right, so using my protractor, I find out that it's not a 90-degree angle, but a measure of the angle is 101. That makes it obtuse. Okay, and that's how you classify a triangle. Make sure you understand these ideas here, and have those memorized. Let's move on. All right, there's the line that goes across. That means we're at a place in our notes to write a summary, and that means we're moving on to another section. So take a few seconds, look back over your notes, make a real quick summary of what it is, solidify in your brain what it is that you learned in this first part of the video under 1.5, okay? And then come back and put me on pause and come back and check for the next set of video information. Okay, 1.6, let's take a look at this. We have a couple of I can statements on your student learn map. I can apply the angle addition postulate, which we're going to work with up front first, and then I can write an equation or relationship when working with an angle bisector. Let's start with this idea of angle addition. So suppose I have two angles that share a common ray, right? And so it's just basically two angles that are pushed up next to each other. One of the angles has a measurement of x degrees. One of the measurements is y degrees. And what we need to know is that if we were to take these two angles and add them together, we get some x degrees plus y degrees equals some total z degrees. Very much the same idea of segment addition. I can add smaller segments to get larger segments. In this case, smaller angles get added together to get larger angles. Okay, so what we discover is the measure of this angle plus the measure of that angle equals the whole measure. Let's write that in words or symbols. So the measure of angle ABC, take a look at that drawing and make sure you see where angle ABC is, plus the measure of CBD, that's that one right there, equals the measure of ABD, this whole thing. Okay? Now my arrows could be pointing up, it doesn't matter, but those three angles are distinct different angles, and when I add the two smaller ones, I get the bigger angle. All right, let me have you take a look at this problem, this example, and go ahead and see if you can find out what the big angle's measurement is. Go ahead and put me on pause and see if you can do that on your own. All right, hopefully that was pretty easy. That equals 75 degrees for that big angle. All right, let's see how we do on this next problem. Now I'm going to actually switch the slide to be able to see this thing a little bit bigger in your screen. So you can just put it in your notes, continue it here in just a second. Okay, hopefully you can see that really quite well. And so we're looking at this problem, and I want to know what is the measure of, angle BAD. Okay, so I can look at that. Here's B, and I'll just trace it out. Here's B, here's A, it's always in the middle, up to D. So what kind of angle is that? That's definitely a 90-degree angle. I can see that from my protractor. So that's a pretty simple question. Let me ask you another one. All right, now that's a little bit more difficult. Okay, find X. So to do that, you have to realize that you have to write an equation when you're trying to find X. To do that, you're going to use the segment or the angle addition postulate. You're going to realize that this plus this equals that 90 degrees. Go ahead and write your equation, solve for X, come back and check your work. All right, I got 12.14 if I did my math right. Hopefully you got the same thing, and if you got 12.4 and we're a little bit disturbed by that, don't worry about it. You're in geometry now. You can deal with fractions and decimals. All right. Let's try your hand at this one. Put me on pause, come back and check it. Hey, if you got X equals 6, you got the number one wrong answer. Unfortunately, that's not the question. Go back and look at the problem, make sure you answer that question. All right, there you go. That's more like it. Hopefully you got that information. You just take the 6 and plug it into the respective expression, get the equation, or get the correct number. Now working with an angle bisector, it actually cuts an angle in half. So if I'm told that middle ray is an angle bisector, this is what I know. I know that that angle and that angle are the same. Okay? Okay, so in this problem, we see that BC is an angle bisector. And so we need to have a question. Let's have you find X. Okay? So you're going to have to write an equation. Those two angles, those two smaller angles are congruent, right? So just like when segments are congruent, we can set the two expressions equal to each other. Put me on pause and see if you can set up the equation and solve. Okay, if you did your math right, you got a -5 on there. that means that you can't, first of all, you can't have a negative angle. That means that if you did that work right, that means that my problem that I gave you is fundamentally wrong. It had the wrong number. It should have been a -7 in the problem, but no worries. Did you set up the equation at the very beginning where it says find x? Did you set it up like that? If you did, you understood the dynamics, the geometry of a problem like this. If you have an angle bisector, the two angles on both sides are congruent to each other. In other words, they're equal to each other. Okay, there's my big dark line. You're at the end. I'm at the end of my slide. We're going to just write summary. If you need to do this on the next page like I would, then you go ahead and do that. Take a few moments and do a summary of 1.5 and put me on pause, come back, and we're ready to go on to our do it problems. Okay, there you go. We're ready to do our try it problems or do it problems. I'm going to zoom in on these so you can see them better, and then you're on your way. And there you have it.